Let's look at the Laplace transform of e to the at. So that's Laplace transform of e to the power of at, where a is a constant, and of course t is our independent variable. So we're looking at a situation similar to when you have x on the horizontal axis, y on the vertical axis, or sometimes instead of y it is f of x on the vertical axis. All right, in this case what you have on the horizontal axis is t. All right, sometimes, well, generally representing time, some function changing over time. So the t-axis, horizontal axis, and then of course the vertical axis is f of t. Now, before we look at that, what is it that we're aiming at? We want to derive the Laplace transform of e to the at. You have tables of Laplace transforms, and in exam you're given a table of Laplace transform. All right, and what you'll have in the table here, for example, this table is from Paul Dawkins at this website here. All right, but here, this, according to this table, the Laplace transform of e to the at is 1 over s minus a. We want to see where that comes from. We want to derive it. All right. So Laplace transform of e to the at. So generally, the Laplace transform of any function is the integral from 0 to infinity of e to the negative st of the function, in this case e to the at dt. We're integrating with respect to t. S is a function, a constant. Now, let's look at this. We have two functions in t, e to the negative st and e to the at. So we're going to use integration by parts. Remember your integration by parts formula. The integral of u dv equals uv minus the integral of v du. Okay. Now, we're going to use the e to the negative st as our u. All right. So u is equal to e to the negative st, and dv is e to the at. All right. Now, we need du. To get du, we have to differentiate e to the negative st, and using the chain rule, which is in differentiation by substitution, you get negative s e to the negative st. And to go from dv to v, you have to integrate. Integration by substitution would give us e to the at over a. All right. For the chain rule and the integration by substitution, you could pause the video and work it out separately, saying that you have a e to the u, all right, and so on, and you work that out, and you will see that gives you e to the at over a. Now let's write the integral. So the integral of e to the negative st of e to the negative st e to the at dt is equal to, all right, so the e to the negative st is u, is equal to u, which is e to the negative st. So the integral of u dv is u times v. V is e to the at over a minus the integral of v is e to the at over a du, which is negative s e to the negative st dt. And remember, you're integrating from 0 to infinity, so this is 0 to infinity, right? And this here goes from 0 to infinity, all right? So that's what we have there. Now let's simplify this. This part coming down this way, right? Let's put in, and by the way, let's put the put this in square brackets. We have two boundaries. The infinity is the upper boundary and the 0 is the lower boundary. Now the upper boundary, e to the negative s times infinity, but s times infinity is infinity, so it's e to the negative infinity. But e to the negative infinity is 1 over e to the positive infinity. Is 1 over e to the infinity, all right? That multiplies e to the at. A times infinity is infinity over a minus, let's put in the 0 boundary, the lower boundary, e to the negative s times 0 is 0, and that multiplies e to the at, which is e to the a times 0, which is 0, over a, all right, minus what now? Let's look at this. We have a negative here and a negative here, so it's going to be a plus. We have constant s and the constant under here a, so this is s over a, and then integral from 0 to infinity. So we put the s over a outside the integral sign, so we're going from 0 to infinity of e to the negative st e to the at dt, all right? Now let's see what happens here. 1 over e to the infinity, 1 over an infinitely large number is 0. This would be 0 times e to the infinity, but you can't have s, the value of s, set in such a way that 1 over e to the infinity decreases faster than e to the infinity. So it goes to 0. So 0 over a, which is 0, minus e to the 0 is 1, times e to the 0 is 1 over a. So this amounts to negative 1 over a, alright? Plus s over a. Now what do we have here? Integral from 0 to infinity of e to the negative st e to the at dt. Alright? Now here, what we're looking at is the Laplace transform of e to the at. So the Laplace transform of e to the at equals this. So the Laplace transform of e to the at is equal to negative 1 over a plus s over a times the integral from 0 to infinity of e to negative st e to the at dt. But hold on. What's the Laplace transform of e to the at? It is this. The integral from 0 to infinity of e to the negative st e to the at dt. Right? And we had it up here earlier. Is that? So we might as well just write it like that. So we have the Laplace transform of e to the at equal 1 over a plus s over a times the Laplace transform of e to the at. Alright? So now, let's subtract all of this from both sides. The Laplace transform of e to the at minus s over a Laplace transform of e to the at equals 1 over a. Is it 1 over a? Oh, negative 1 over a. I left off the minus sign. It's negative 1 over a. Alright? Let's factor out the Laplace transform of e to the at. It's a common factor here. So we have the Laplace transform of e to the at 1 minus s over a equal negative 1 over a. So the Laplace transform of e to the at equals, let's divide by 1 minus s over a. So it's negative 1 over a divided by 1 minus s over a. Now, let's deal with this using our knowledge of fractions. This is negative 1 over a all over. We could use common denominators here, or you could draw the line and find the LCM if you want. But let's use common denominators. You see the 1 is the same thing as a over a minus s over a. So we have common denominators, right? So now, the Laplace transform of e to the at is equal to, so we have negative 1 over a up top over. This is the same as a minus s over a. See that? Alright, this is equal to, remember, you have this up here divided by a fraction. Remember what to do. Whatever you have up here, 1 over a, must multiply the reciprocal of that fraction. So it's a over a minus s. Alright? So a will cancel a. What does this give you? Equals negative 1 over a minus s. But if you multiply both top and bottom by negative 1, the negative 1 up top would be a positive 1 over The positive a would be negative a, and the negative s would be positive s. So what you would have is 1 over s minus a. So what you have here is that the Laplace transform of e to the at is equal to 1 over s minus a. 1 over s minus a. Let's look back at the table. Right. The Laplace transform of e to the at is 1 over s minus a. But this was a matter of deriving it. In exam, you'd have a table of Laplace transforms. So you wouldn't derive it unless you're asked to derive it. Alright, so I'll see you in the next video. So stay tuned.